What is the mass of 248.0 milliliter sample of oxygen gas at 100 degrees Celsius and 0.500 atmosphere? Whenever you deal with gases, you can assume ideal behavior unless the question specifies otherwise, or if information about deviation from ideal behavior is given. A sample of gas is said to be behaving ideally if it obeys the equation PV equals nRT. In this equation, N is the number of moles of gas particles in the sample. P is the pressure of the gas sample. V is the volume of the gas sample. T is the absolute temperature of the gas sample. When we say absolute temperature, we mean the temperature in Kelvin. Finally, R is the ideal gas constant. The numerical value for R depends on the units for pressure and volume used in the calculation. It's a good idea to memorize its value when pressure is in atmospheres and volume is in liters. In this case, the R is equal to 0.08206 liter atmosphere per mole per Kelvin. If you use this value for R, make sure you express your pressure in atmospheres and volume in liters. Let's see how we can apply this equation to our problem. We are being asked for the mass of the gas. None of the terms in this equation, PV equals nRT, refers to mass. But by now, you should know how to convert moles to mass. Therefore, the first thing we need to do is solve for the number of moles of gas molecules in the sample. That is, solve for N. Rearranging the equation, we see that N is equal to pressure times volume divided by R times T. Plugging in the numbers from the problem, pressure is 0.500 atmospheres. Volume is given in the problem as 248.0 milliliters. We plug it in as 0.2480 liters. For the denominator, we plug in 0.08206 liter atmospheres per mole per Kelvin as the value for R, and plug in the absolute temperature in Kelvin. The problem gives us 100.00 degrees Celsius. We simply add 273.15 to the Celsius temperature to get the absolute temperature in Kelvin. Carrying out the indicated calculation, we find that the following units cancel out: atmospheres, liters, and Kelvin. And we get an answer of 0.004051 moles of oxygen molecules. By now, you should know that oxygen molecules are diatomic. There should only be 3 significant figures in this answer, since our least precise term in the calculation has only 3 significant figures. But we keep an extra digit because we are carrying this result into another calculation. In this problem, we are looking for the mass in grams. To convert moles to grams, we simply multiply by the molar mass. The molar mass of oxygen is 32.00 grams per mole. 0.004051 moles of O2 times 32.00 grams per mole gives us an answer of 0.130 grams. The correct answer is A.